Hey guys, what's going on? It's Mr. Sanchez here coming at you with an AP Calculus lesson. Alright, today we're going to be focusing on Riemann sums, definite integrals. Oh, my bad, not definite. Important part, indefinite. No, yeah, never mind. No, my bad. It is definite integrals. And what, this is just fancy verbiage for, what we call area under the curve. Okay. Before we begin, we got to go over some notations, right? So what do I mean by area under curve? So, if I draw a little graph right here, right? Area under the curve represents this shaded area. So see how that's underneath the line? That's my area under the curve. And then technically speaking, this part is also technically under the curve. We're not going to go into the specifics why that is, but that is considered area under the curve. And there's an area here. It starts, let's say we wanted this area here from A to B. That the way we would represent that in math is called using a definite integral. So you might have seen this notation before. It's called the integral from A to B, right? And let's call this f of x. F of x dx. This is a definite this is an integral. And what do the integrals tell us? They tell us the area under the curve. Between A comma B, right? So that's what it tells us. And it's like, well, how do we calculate this area? The way you would calculate this area, there's multiple ways, but the way we're gonna be doing it, at least today, is we're gonna be using rectangles. All right. So what we do is to find this area is you draw a point here and draw a rectangle. You draw a point here and a rectangle, and you just make rectangles until the next point right here, and then we're gonna find so what we're gonna do is called an approximate sum, where we're gonna approximate it. It's not gonna be perfect, but we're gonna try and approximate our area like this using rectangles, right? Later on, we're gonna go over how to find the exact area, but for now, we're gonna do an approximate. This is and this is called a Riemann sum, right? This is a left hand sum, and we're gonna go over left hand sums, right hand sums, midpoint sums, trapezoid sums. There's a lot of sums, right? We're gonna do this all by hand, but on the AP exam, it is mostly done by calculator. All right, so we're gonna look at a specific symbol because the area of this rectangle, right, of this curve, is gonna be represented by this symbol. Let me go ahead and move this. This is not a good place for this. Let's put this here. That's a better spot. All right, so this whole area, notice how it's let me see if I can get rid of the green. Notice how the area is represented by these little rectangles, right? Right, so it's all of these rectangles. And sometimes we're going to go over, sometimes we're going to go under. It doesn't matter. Anyways, let's assume, for our sake, that this length of this triangle is called delta x, right? And then the height of this rectangle, I said triangle, rectangle. And the right here, that's going to be f of x sub 1, right? We'll call that an x value, right? So the way you do this sum, it's the area of rectangle 1 plus the area of rectangle 2, area 3, area 4, area 5, area 6, area 7, area 8, area 9, right? So, you're going to see that, notice how it keeps going up, up, and up, up, and up. We can write that whole thing as the summation from x equals, I believe, 1 to I. So this is x sub 1, and this is x sub I. Delta x, right, because that's our base, times our height, f of x sub I. Okay? I'm sorry, it's not I. It is I is equal to 1, and then this is an n. So n represents which point you're starting at. So this might this might look confusing, but this x value, that's x sub 1, that's x sub 2, that's x sub 3, 3, 4, 5, 6, 7, 8, 9, 10, right? So instead of writing all of it right here we'll write n equals 10. So what this tells me is to basically do delta x, because that's the height right here, this little height, the base, times the height, which is f of x sub 1, plus delta x times the height of the second rectangle, plus the height of the third, and then you're gonna keep doing that dot until you reach the last one, which will be x sub n, whatever, which in this case was 9, 10, right, or 11. Yeah, so this is called summation notation, and we're gonna need this later on, okay? But that's basically the gist of what the concept of what we're gonna be working on with today. And it looks really complicated, but once you see what we're actually doing, it'll be really, really easy, okay? So this is an introduction. Let's go to the actual problem, okay? Right here it says, for each problem, approximate the area under the curve, and it's an approximation using 4 left endpoint rectangles, right? And they give us this function, and it's gonna be from -3 to 5, okay? So I'm gonna just draw this graph. We don't have to draw this, but I want to show you guys what this looks like, all right? Just to give you guys an idea of what we're doing. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And let me extend this some more because I don't know how low I'm gonna go. All right, and these are not to scale, so if you could draw yours on graph paper, that'd be better. All right, x plus 4 is a line. We should know how to draw that line. It's slope intercept form. Right, we're gonna start at 4. 1, 2, 3, 4, and you're gonna go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. You're gonna go up 1 over 1, up 1 over 1. Right, and your line's gonna go straight like this. All right, it's not perfect, but that's my line all the way until you reach 5, and this would actually be done better if I drew it perfectly, so it's gonna bug me. Anyways, what we're gonna do is we're gonna start at -3, right? -3, 5. That's gonna be 1, 2. Oh my gosh, this graph is so bad. I have to redo it. I'm sorry, guys. We're gonna draw this perfectly because otherwise it's not gonna work, and it's gonna really mess up with the scales. So this should go all the way up to 9 if I do this correctly. All the way up to 9 because I know how to add. Alright, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Alright, and we start at 4. 1, 2, 3, 4. That's my y-intercept. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Alright, so this is a more accurate graph. And once again, you don't need to draw the graph, but it really helps. Alright, and it says do a left-hand sum. So a left-hand sum means that your endpoints are going to be on the left-hand side. But we want to find, notice how our formula is technically the summation of x of n of I equals 1 to n, such that x sub n, x times f, let me write the whole thing. Alright, we know there's going to be 4 rectangles, right? So we want to use 4 equal, all right? So the way you find what your delta x is going to be, your delta x, to find out how long that rectangle needs to be, we're gonna call this A and B. You're gonna do A plus B over n, and this is your n. So my delta x is gonna be -3 plus 5 over 4, which is gonna be what is it? 2 over 4, which is 1/2. No, that can't be right, isn't it? No, my bad. It's subtraction. It's B minus A. B minus A. I had them mixed up. I'm sorry. Yeah, it's been a while since I've done this. Minus -3. This makes more sense. You're going to get 8 over 4, which is 2. So what does this 2 mean? That's how long our rectangles are going to be. Like the base of our rectangle. Right, so it's going to be delta x. There's going to be a delta x. And then our height is going to be f of x, right? So our delta x is a size 2. Alright. You start here for your left-hand side. You see how it says left endpoint rectangles? This is called the left sum. And this is your start point. Okay? So we're going to start here. And so we're going to go at -3 plus 5. So it's going to be x sub 1. It's going to be a, which is equal to -3. Then you need your next point, x sub 2, which is going to be x sub 1 plus delta x, which is going to be -3 plus 2. So my next point where I'm going to do my rectangle is going to be at -1. You have x sub 3, which is going to be -3 plus 2. X sub 2 plus delta x, which is -1 plus 2, which is 1. And then you're going to have x sub 4, which is going to be x sub 3 plus delta x, which is equal to 1 plus 2, which is 3. Alright, we're not going to include the 5 because we're not going to use that for our sum, okay? So these are the points we need to find. The x values where we're going to start, alright? So x sub 1 means you're going to start here at -3, right? So we need to find f of -3. And then you're going to make your rectangle 2 spaces wide. Because that's what my delta x here is, right? Delta x is 2. And then I'm going to draw another rectangle. And this time it's going to be at f of x equals -1. So f of -1 times. And you're going to go across 2 spaces. Draw my line. Because it's always 2. Because that's what my delta x is. And then if I do this correctly, I should end up with a perfect sum. So then after one, then we're going to start at 1. That's f of 1. And you're going to go across 2 spaces. Because that's how we roll here. Right? And so this point should be more over here. Ignore that one. And then the last one, we're going to have f sub 3. And f sub 3, because it goes 2 spaces, it should stop at 5. It should stop right here. So, you see we have 4 equal rectangles. And our goal is to find this area. What is this area? So let's find it out, right? So it's not going to be that hard. You're just going to plug in these values into your equation here. So the integral from a to b from -3 to 5 from f of x dx is going to be equal to so it's going to be delta x, which is 2 times f of -3 plus 2 times f of -1 plus 2 times f of 1 plus 2 times f of 3, right? Notice how all of these 2's factor out. This is technically delta x times f of x plus sub 1 plus delta x times f of x2 times delta x times f of x3. The notation is weird, but this is how it happens, right? This is 4, right? Notice how they all share a delta x or a 2. So I'm gonna factor out my 2, and it's gonna be 2 times f of -3 plus f of -1 plus f of 2, f of 1 plus f of 3, right? And now all I gotta do is find those values, all right? And it's not gonna be that hard because this is gonna be negative 3 plus 4, right? Negative 3 plus 4 plus negative 3, negative 1 plus 4 plus 1 plus 4 plus 3 plus 4. And what am I doing it? I'm plugging everything into this equation right here. That's where I'm getting these numbers from. All of that times 2. And you can use a calculator for this. I don't really care. Negative 3 plus 4 is 1. Plus negative 1 plus 4 is 3. 1 plus 4 is 5. And 3 plus 4 is 7. All right. And then you're going to get 2 times. And then 3 plus 7 is 10. Plus 5 is 15. Times 16. Which gives me an area of 32. Okay. And this is... And you notice how there's all this empty space here? I'll use a different color. Especially blue. You see how there's all this empty space missing? This is going to be what we call an underestimate. Okay? Why is it an underestimate? Because f of x is increasing. And we are using a left hand sum. Alright? So it's increasing if we use a right hand sum. If it's increasing and we use a right hand sum, then it's over. And then, alright, so, and then the opposite is true. So if we have a decreasing function and use a left hand sum, then it'll be an overestimate. And if it's a decreasing and you use a right hand sum, and it's going to be underestimate. Alright, and that's basically it for this video. Alright, guys. Bye. This is the left hand sum. We're going to do a right hand sum next.